Thanks for joining our live cast today to discuss the new Aqualab TDL2. My name is Zachary Kare, and I'm a lead food scientist and isotherm application specialist here at Meter Group. I also host a brand new podcast that is currently available on Spotify, Apple Podcasts, or wherever you listen to podcasts. It's called Water and Food. So please check it out and follow or subscribe to hear upcoming episodes. Let me start the live cast today by saying welcome. Since you are existing TDL customers, we are excited to share this information with you about how we've improved this instrument to serve you better. But first, I'd like to say a big thank you for your business and continued partnership. At Meter Group, we have a lifelong customers, and we appreciate any opportunity to communicate with clients like you. And to show our appreciation, we're also running a very generous trade-in promotion through March. So if you like what you hear today and want more information on how to get the new TDL2, or if it's time for your annual recalibration and you'd like to get the newest generation of this instrument, you can speak with your regional application specialist. If you don't know how to reach your application specialist, we can help you out after the session today. Today, I'm joined by the head of instrumentation at Meter, Zach Campbell. Zach, why don't you say hi? Tell us a little bit about your role at Meter and what you do.
Yeah, good morning, everyone. Just wanted to echo thank you all for attending. I really do appreciate that. So as Zach mentioned, I'm the director of instrumentation here at Meter, and what that means is that I have the privilege of managing our water activity meter portfolio, and that includes interacting with clients to understand their needs better, in addition to overseeing application support and also new product development as well and technology development.
All right, thanks, Zach. So today you're with the Zachs. Today we're going to start off with a brief agenda. First, we're going to talk about the theory of operation for our current TDL instrument and cover how the equipment works. Then we will be introducing the new TDL2 and discussing what's new with the device and how it compares to the previous version. And then we will wrap up with a Q&A section. I'd like to encourage everyone listening to please submit any questions in the question pane. We'll answer questions at the end of the presentation, and if we don't have time to answer all your questions, we will certainly follow up with you to address all inquiries. Now, Zach, what does TDL actually stand for, and what do these instruments measure?
Yeah, that's a great place to start. Now, most of you are existing TDL clients, so you'll have some idea. TDL stands for a Tunable Diode Laser, and it's, of course, a water activity meter that measures the water activity of a sample using a tunable diode laser. Now, that's different from our existing instrumentation, such as the Aqualab Series 4 and other capacitance-based sensors. So the TDL actually uses a tunable diode laser to measure the vapor density in the headspace. Now, what that means is that it is only sensitive to water vapor and even specific isotopes. It operates over a narrow enough bandwidth that we don't see any influences from alcohols or other contaminating molecules that you would with something like a dew point sensor, where it will co-condense on that mirror and effectively change the measured dew point temperature. Now, on capacitance sensors, you can get some measurement of volatile containing compounds up to very low concentrations, in the neighborhood of 3 to 5%. But what you'll see is still an impact on that. And that's true of all capacitance and electrolytic based sensors. And there's ways to work around that, such as using filters. But still, the TDL represents our best application for high concentration volatiles or any products that are going to damage or poison capacitance based sensors.
And you already touched on this a little, but why are other methods like the dew point or capacitance sensors affected by volatile compounds? And maybe you can explain this figure that's on the screen.
Sure. Yeah. To the first point, again, I mentioned it briefly, but dew point based sensors, when a volatile, and to define a volatile, it's a compound that will go into the headspace of the chamber and co-condense on the mirror. So a good example of that is ethanol. So if you have concentrations of ethanol, then they will change the perceived and measured water activity when using a dew point sensor. So this graph here is showing the absorbance peak of water from the tunable diode laser. So you can see it operates over a fairly narrow bandwidth. We don't have nanometers listed on here. We just have a scan position. But this entire range is going from about 1830 to 1840 nanometers. And so we're able to really pinpoint that water absorption peak in a way that it isn't influenced by other volatile containing compounds.
And who needs this technology, and what market segments are we currently serving with it?
Yeah, that's a great question. So again, high concentration volatiles, which in foods is actually a relatively low overall total concentration. We're looking at anything above 3 to 5%. And because you are existing TDL clients in the audience, you probably have an application that called for that. If you have any questions, feel free to reach out to our support group, and we can help you better understand how maybe the product might interact with the different sensor technologies and pick out the right sensor for you.
And how long has Meter Group been making the TDL, or when did it first become available?
I believe we released it in 2014.
And right now, what types of national or organizational compliances does this technology have?
So our friends in pharma will be aware of the USP 922, which is a standard that was just recently accepted, and the TDL is called out in that standard. In addition, we're currently working on AOAC approval, and we should have first action approval for the method to measure water activity of high concentration volatile containing compounds very soon, and I'd say probably the next couple of months.
All right, and now let's introduce the new TDL, or the TDL2, as we're calling it. And let's start off with a simple question. Why did Meter Group decide to change it? You know, our clients have been happy with the existing version, so why make any changes now?
Yeah, that's a great question. And as you mentioned, our clients had more or less enjoyed what the TDL brings to the table. It does what it is touted to do as far as measuring water activity in the presence of volatiles. But we did release it in 2014, and as many of you are aware, the rate of technological improvement has just accelerated even since then. So what we really are striving to do at Meter is to provide a total solution. Now, where the TDL fits into that, the new TDL that is the upgrades that we went about implementing were to really enable this to be a part of the total solution and to leverage the Meter software platform Scala. And so what that'll allow our clients to do is to leverage the data that they're collecting and use it to make meaningful decisions based on the particular product insights. So it really enables this to become an IoT device.
All right, and let's go into a little more detail on the upgrades that you just briefly mentioned. And let's start off with the new hardware. So what can you tell us about the updated temperature control for this device?
Yeah, so the updated temperature control in those that would be measuring high water activity compounds, such as above 0.9 all the way up to close to water. One thing that you would see periodically is condensation within the chamber, and that can occur when you put in a warmer sample than the actual chamber temperature. So what we're doing is we're actually controlling the temperature in a way that overcomes any internal temperature gradients. So this should alleviate the issues with condensation that you're seeing. It also provides better control of the sample temperature and allows the sample temperature to come to equilibrium a little bit faster than what we've seen in existing TDL.
And what about the new processor? How does this compare to the original version?
Exactly. So like I mentioned, I think before, we pretty much tapped out the hardware resources on the processor itself. In order to continue innovating and making new improvements to the firmware, we had to upgrade and update that processor. So that was our justification here. And what this really allows us to do is to continue to push that out, push out new features, push out updates to our clients that the existing TDL does not allow.
And then finally, are there any upgrades to the sensing capabilities?
Yeah, so as I mentioned before, the water activity measurements aren't influenced at all by volatile compounds. However, there is a phenomenon called pressure broadening that is the nature of the TDL-based technology. And so in order to incorporate that, we've always had a pressure transducer on the instrument itself. But one change that we made is actually incorporating that into the chamber itself rather than on the motherboard as it currently stands, which isn't part of the actual measurement chamber. And so that allows us to better correct for any pressure changes.
Great. And now that we've covered the hardware, let's move on to the software. For this device, is water activity being calculated the same way, or is the TDL2 using some type of new method?
Yeah, so this is the most exciting part really about the new TDL. is that by incorporating that new processor, our scientists were able to go back to the drawing board and really take a look at how we had calculated water activity from those optical absorbance values. So the new TDL uses an entirely new method for computing the water activity from the absorbance peak. Now, what that allows for is just a more consistent, more robust measurement. So our clients will see improved performance on a day-to-day basis with the new and improved TDL.
And how does the TDL2 integrate with Meter's cloud-based system called Scala? You mentioned Scala before. So what is Scala and why is it important for this new instrument?
Yeah, so Scala is our food manufacturing software platform. Now, I say food, but it also ties into other pharmaceutical manufacturing and chemical manufacturing as well. And what it enables our clients to do is to take the quality measurements and to really combine that with the process data that they're already collecting, or we can help to collect that process data. And so it brings in some potential insights into that interaction between product and process that may not have been available to begin with. So the TDL integrates with that. And now what that allows us to do is to provide remote updates. So that's new features, new updated calibration, and also provides a traceable database of your measurements and of the calibration of the instrument itself. And this is 21 CFR Part 11 compliant.
And will users have control on opting into Scala?
Yeah, that's another great question as well. So remote updates can kind of it can be a scary thing for some clients, and because of the rigorous process that needs to go through for verifying and validating new firmware and new software. So we enable that to be completely controlled as far as when and how those updates are done. We also allow for seamless rollback to previous versions if there's ever any compliant issue as well.
And are there any updates on the speed of this TDL2? Last year, Meter introduced the Aqualab 3 for 1-minute moisture content and water activity measurements. Will this new instrument also be capable of 60-second readings?
Yeah, so this Scala integration really enables the usage of 1-minute water activity. So I'm happy to announce that we will be releasing that feature for the TDL, which has really allowed our clients to change the workflow of their lab. The throughput effectively can quadruple in certain cases. So this has really been a major improvement for our existing dew point based clients.
And my last question here is, I know it hasn't been implemented yet, but can you also talk about how Meter Group will be streamlining the calibration process?
Yeah, so it'll all be integrated within Scala. So as I mentioned, the verification and validation that you perform every day or every shift will be captured within Scala, and it will also be able to walk technicians through. So as a manager, you can ensure that those measurements are being followed and the SOPs are being followed.
All right, great. So we've covered the hardware and the software. And now I'd like to turn this over to the listeners and see what types of questions that we have out there. I am going to put our contact information up on the screen. So here's my email address as well as Zach's. And there's also the number for our Meter food sales team. We have a couple questions coming in. The first one is, when will you stop supporting and servicing the old TDL?
So the release of the new TDL is slated to go out in the next couple of weeks. At that point, we'll begin transitioning the sale to the new TDL. Now, if there are existing quotes, we will be honoring those, especially if clients would like the legacy TDL. As far as support is concerned, we have not made any announcements of end of life. Our traditional time frame is 5 years, so we'll continue to be supporting the TDL for at least the next 5 years.
And I just got a question that came in that says, I like the idea of automatic updates, but I'm concerned that it might cause issues unexpectedly. Can you touch on that?
Again, yeah, those are, so the entire process is opt-in, so, and you have complete control over when and how those updates are applied. Additionally, we go through a very rigorous process to QA new firmware before we release it to you.
And I just got a question from Ray. Ray, thanks you for your question. Is this 1-minute water activity determination applicable for low water activity samples?
So in our testing of the method, it's applicable over the range of measurement of the TDL. Typically, we've gone all as low as zero point 0.1 all the way up to basically water, and this method is applicable across that entire range.
What about down to 0.05?
0.05 we haven't validated yet, but I would anticipate that it should perform at that level.
Great, thanks, Zach. Another writer puts, I'm in the middle of a research project. Should I wait to upgrade?
Yeah, that's a great question as well. My advice on these kinds of questions is typically you want to change as little as possible during your experimental process. So as that pertains, I would implore them to reach out to us, and we can talk through if there's been any major changes in firmware that could impact the readings that they're getting before they make that update.
And someone else writes, have you considered putting TDL technology in your vapor sorption analyzer?
Yeah, that's a great question, and that is something that we have considered and we're looking into currently. So if there are any clients in the audience that would find that to be an interesting application on their product, then we'd love to have the conversation with you.
Okay, and Andrea, thank you for your question. She writes, will the ability to control sample temperature cover the same temperature range as the legacy TDL?
Yeah, so that's a good segue into the specifications of the new TDL2 are going to be identical to the existing TDL.
Okay, we have another one here from Chris. Thanks, Chris. I understand that Scala is required for 1 minute water activity. If you are not using Scala, will we see faster measurement times compared to the legacy TDL?
The legacy TDL and the TDL2 should have comparable measurement times. We have seen slightly better performance, but it's going to be on a product basis.
Great. Well, from here, we're about at our time limit. If we didn't get to your question, your regional application specialist will be reaching out soon. Don't forget to ask him or her about the trade-in promotion that I mentioned at the start of this presentation. Also, if you are listening today and interested in being a guest on my Water and Food podcast, please let me know. We'd be happy to discuss the podcast more with you. I just want to finish by saying that we really appreciate your time today. Thank you for attending, and thank you for helping us continue to evolve our technology. See you next time.